Hello, we're going to be talking about user input in this video. So let me present this. All right, so we talked about the Hello World program last week, and we also did some computations. So all of these programs that we wrote, they put some sort of text messages on the screen, which is also referred to as the console. So all of those are examples of computer outputs, right? Something that's displayed on the screen. So you've seen many other examples of what a computer output can do, such as on a computer monitor, you have seen graphical user interfaces, such as your Mac, the, 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 the user, the application windows. Also the same thing on a Windows machine. You have all these menus and windows and all sorts of things that are graphical user interface related, or if you play games, I'm sure some of you do. And these are the 3D virtual world that is shown on your monitor. So those are visual outputs. There are also other types of outputs, such as music. Right? Probably used to have a computer that play music, and nowadays it's probably on your phone. So these are also audio audio outputs. And then there are other outputs that machines can have, such as if the machine can control robotic arms, let's say an automated factory that perhaps are building cars and stuff. So those are also outputs. Now, going back to our Hello World program, every time we run it, it does exactly the same thing, right? And probably so do the assignment one that you've done. Now, that's kind of really gets quickly boring, not to say that it's not that useful. And the reason for that is because we cannot interact with it, right? We cannot give it inputs to our Hello World program. And when we think about it, we really interact with our computers and other electronic devices all the time, using different inputs. To a computer, the most basic input is the keyboard. We type on the keyboard all the time. You type your Python code on the keyboard, and you use your mouse, or on a Mac, you use your trackpad. Um, what about your phone? Well, most of us has a smartphone, and that has touch screen. So the touch on those screen are also inputs to it. Smartphone has many other inputs, such as the microphone, such as the GPS, which tells the smartphone where it is in the world. And also, smartphone has other sensors, such as the light sensor, which help you to maybe turn the display brighter in the sunlight and turn it dimmer when it's at night, and gyroscope, and just all sorts of other inputs that that these electronic devices can can have, that we interact with them through these inputs. But okay, well, given all these inputs, let's start with the most simple one. And on a computer, that is also the most common one and the most useful one, and that would be the keyboard. And let's see how in Python we can read from the keyboard. And here is the example. Let me show that on presentation mode. Oh, wait, what? Presentation mode. There we go. So the way a Python program can read from the keyboard, basically read what the user type on the keyboard, is using the built-in function called input. Okay, so input is just another function like print, except actually it's the counterpart of print, right? Print is the output, put something on the screen. Input is read something from the console. Okay, and the way it works is once you call the function input, your program is sort of in a suspended state. Input sits there and wait for the user to type something. And as soon as the user type something and hit enter or the return key, then input is going to return whatever user type on the screen, on the keyboard, to us. And in this case, we are capturing whatever the user type into a variable called name, right? We're assigning whatever the input returns to the variable name. So let's actually see that in action. Okay, so I just run it. And then it actually, when I call input, you notice that I also give it a string. Okay, and input would actually put this string on the screen. So this string usually contains a message to the user, telling the user what they should type. So in this case, we're asking for the user, what's your name? For the time, my name, just type Zibin, and then I press enter. And well, the program is done, because what else did we do after we get the user's input from the keyboard? Well, nothing. So it says it's finished. Okay. So right then, what can we do with what the user type? Well, we can. The simplest thing is print it back out, right? We can just say, you said your name is. I'm going to put a single quote here just to make the print out nicer. Okay, so let's run this again. I'm going to say, what's your name? My name is Zibin. So there, you said your name is, in quotes, Zibin. Right. So another thing, a very kind of tiny little thing here is, you notice I put a space after the question. So if I don't have the space and I run it again, well, actually the space show up here, right? If I don't have the space, and it's fine, it works. It's just my answer would be crammed right up against the question. So that's why I have a little space here to kind of separate things to make them look a little nicer. Okay, so that is a very basic example of how to capture what the user types on a keyboard and how you use it. Let me just go back to my slides, make sure I didn't miss anything. Okay, so again, input is a function, and we call it. It waits for the user to type, and it will, as soon as the user hits the enter and return, it returns what the user types. Okay. Now this message in that we pass to input, it's called an argument. The reading refer to it as a parameter, but I think they're more or less the same thing. But I think the more correct terminology is that it's an argument. This argument has some meaning to the input, right? It's a message that's displayed on the screen before input waits for the user to type something. And finally, input returns whatever the user type. We capture that, we store it in the variable name. And we can use the name just as we use a variable any way we want. Okay. All right, so let's move on and let's actually look at an example that we did last week that actually calculates the perimeter of a square. Remember, we actually hard code the side of the square to a number, which means if we want to calculate the perimeter of a square whose side is of a different length, we have to change the source. It would be a lot more useful if we actually allow the user to subtype the length of the side and we just calculate the perimeter. So it's something that we can do very easily. Sorry, wrong one. I believe I have the code somewhere down here. Yes. All right, bring that up. Okay, so instead of hard coding the number 5 or whatever number in the source code itself, I can get it from the user. Tell the user, please enter the side of a square. All right, I put a little space at the end. And then once I get the side, I'll calculate the perimeter and print it back out. Okay, let's see if it works. I'm going to just try the same side, 5. What happens here? The perimeter of a square whose side is 5 should be 20. Why is it 5,555? Well, to understand that, we have to understand the type of things that input returns. So this is the result. Input, this built-in function, what it returns is always a string. Okay, that's very important, and that's why I put it in bigger fonts. Input always return a string. So in this case, wrong one. Okay, in this case, side holds the string 5, not a number 5. Now, when Python sees a string 5, we haven't covered this yet, but what it essentially does is it repeats that string 4 times. This is called string multiplication. Don't worry too much about it if you don't know how it works. But it repeats the string 4 times. And that is why the string 5 is repeated 4 times. Okay? That's what happened here. Now, so, okay, fine. So input returns a string 5. What we want is an integer 5. How do we do that? Well, I'm sure you remember, in order to convert a string into an integer, we just say integer and put that thing as an argument to integer, to int. Okay, now let's see if that works. So enter number 5, and there, that's what we expect. This string 5 here gets converted to an int 5, and we say 4 multiplied by 5, and that's how we have 20. Now, and remember why we're going through all this trouble? Oh, I can type something different now. I can give it a side that is 10. It will tell me the perimeter is 40. Or I give it some other, oops, I'm sorry. What happened? I pressed debug. Okay, I'll run it again. I'll just say some other numbers for the side, and it will calculate that for me correctly. Okay. So there we convert it. And then, yeah, now I want you to try this on your own. If you follow through with the video last week, you actually wrote a piece of code that calculates the perimeter of a rectangle given its width and length. Now you should change it so that it gets its width and length from the user. And then you calculate the rectangle's perimeter based on the user's input. So go ahead and give it a try. Okay, so now that we actually asked the user for inputs, which makes our program a lot more useful, but at the same time, it also exposes our program to possible abuse. And what I mean by that is, let's say I'm running this program again, and I'm gonna the program expects me to put in a number. But what if I don't put in a number? I put in something like evil laughs, ha 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 ha. What happens? Well, a program crashed. And if you read the message or you kind of think about it, it's not hard to understand why it crashed, because input returns the string evil laughs, and int would try to convert the string evil laughs into a number, and obviously that is not a number, so the program died. Another thing that can potentially happen is I give it a number, but I give it a negative number. Okay, it's a number, so our program doesn't crash, and it will happily calculate, well, it will happily apply the formula for multiply by -5, and it says the perimeter is -20, even though it makes absolutely no sense that the side of a square is a negative number, right? So here are the two examples that I cited on the slides. And so now you kind of get an idea how a user can abuse your program. And why would a user want to do that, right? Aren't we all nice human beings? Well, yes, we are. But at the same time, there are hackers, I'm sure you heard of them, that they would try to do anything to break your program, to break into your system, to try to steal your information. Or maybe not someone evil, but someone who's just careless, right? They don't read your question carefully. So, or they just make a typo, right? Type something differently from what they intend to type. And finally, there are just users who just want to have some fun, like little kids. Given a chance, kids would try all sorts of things, just because it's fun for them. That's because they like to break things. And there are probably other reasons that user would put in things that you don't necessarily expect them to put in. So, and as we have seen, there are, at least that I can think of, that there are two very broad categories of user input errors. The first is a type error, right? That we're expecting a number, but the user put in a string that is not a number. Now, a type error is a little harder to deal with because it requires basic understanding of exception. We'll talk about that later, but not right now. But we can handle a different type of error, and that is value error. That even whatever the user type is the right type of data, but the data itself has some wrong values. So in the example we just saw, sine of a square really should never be negative. So we will learn how to deal with that in as our next topic using conditionals. So that's the end of this video. There will be another video on conditionals.